you're an IndyCar driver, you have to go fast. But the driver is just one part of a team of dozens of people that are all working together to get that car across the finish line. At any track around the country, that team needs secure, reliable, and redundant connectivity to race data and camera feeds, whether they're in the pit crew, on the engineering team, or here in Indianapolis at RLL Racing headquarters. That's where Crosstalk comes in. RLL Racing brought us here to build them a solution that's portable, works with whatever internet connections might be available, and has redundancy in case internet connectivity is interrupted. It's the type of solution that might just give them a competitive edge on the racetrack. So buckle up and enjoy the ride as we do some IndyCar networking. This video is brought to you by Crosstalk Mobile. Whether you're a top-tier IndyCar racing team or working remotely from your RV, Crosstalk Mobile keeps you connected when it matters. We've got a full stack of truly unlimited 5G data SIMs, routers and antennas that are designed for mobility, and the engineering to design it all around your situation. Call or text Crosstalk Mobile at the number on the screen to speak with real network engineers, not salespeople, or you can visit crosstalkmobile.com for more information. All right, let's get back to Indianapolis. Rahal Letterman Lanigan has been a staple of IndyCar for decades. That's racing legend Bobby Rahal, late night legend David Letterman, and businessman Mike Lanigan. These guys are monsters of the IndyCar racing circuit with multiple Indy 500 wins. So when they reached out to us for help, we immediately said yes. RLL's IT team had two main goals for us. The first one is the one that every IT person watching this is gonna feel in their gut. Their headquarters in Indianapolis was running on aging Cisco Meraki gear, and they were racing towards a brutal licensing renewal just to keep their network running. So our first job is to completely rip out their entire headquarters infrastructure and replace it with Peplink, saving them a serious pile of money in the process. The second reason is the fun one. Every race weekend, RLL gets a live data feed from the track, and they need it distributed everywhere that their team is working in real time, no matter what kind of internet connection each spot happens to have. Now that part sounds almost impossible the first time you hear it, so how did we pull it off? Keep watching and you'll find out. But before we could help the team on race day, we had to build a solid foundation here at headquarters with the help of Andrew Hughes, who runs IT for RLL. I'm here with Andrew Hughes, and Andrew, tell me a little bit about your role here at RLL Racing.
Yeah, I'm the IT systems manager here at RLL. I've been here for coming up on 4 years now.
When it comes to like a typical race, a race weekend or an event, right? What's the role of IT as far as race day comes?
Over the course of the weekend, it's really just a matter of kind of setting a foundation. Everything is interconnected in the paddock to make sure that, you know, from your pit stands to the engineering trucks to even the fuel rigs and viewing stands for our sponsors, those things need to be connected and reliably so. So really from the outset, it's kind of making sure that's all completely set up without any holes or issues and tackling those as they come up.
So when it comes to the actual race, right, you've got live camera feeds, you've got race telemetry, all the stuff that we're kind of seeing on the screens here behind us, but like who needs to see what and why is that important?
Well, I'd say first and foremost, the engineers need to see pretty much anything and everything at the track as it pertains to live feed. So that's broadcast from, in this case, Fox. There's also cameras set up around the track that Fox would also use in terms of their broadcast, but they set them up in kind of a collage of sorts so you can kind of see what's happening at the track, even if it's not being shown on the broadcast per se.
Right.
And then you also have the telemetry that also runs throughout the track. All these things are paramount to knowing where the car is on track, how it's performing, what everybody else is doing, because that really drives kind of the strategy overall. And if any of that gets delayed or hicced up, or there's a hiccup and you don't really have any real understanding of what's happening out there, you're really just flying blind, and that's never a good thing.
solid connectivity at both headquarters and trackside is why RLL called Crosstalk in the first place. So we spent months leading up to our visit designing the solution and planning for every detail of the install, so that when we showed up on site, things would go as smoothly as possible. We started by unboxing, staging, and configuring all the gear for both the data center as well as the remote racing teams.
And what we're doing here is staging these devices. We're basically putting devices that are going to be right next to each other in the various trucks. Truck 45, this one's truck 47. Here's our engineering truck main router. Again, some extra stuff here. Here's the big external access point that's going to be on that engineering truck, as well as a backup network for the engineering truck. And then more stage routers, stage routers, stage routers, stage routers. Peplink all over the place.
Once we had everything staged and labeled, we hit the toughest part of the job, ripping out the Cisco Meraki core and replacing it with Peplink. That kind of swap has to be done after hours, so the Crosstalk team stayed late replacing every piece according to plan and testing as we went, so that the staff at RLL walked in the next morning to a network that just worked.
We're here at the MDF, and what we got to do is they have a lot of Cisco Meraki that we're just switching one for one with these Peplink 48 ports. So luckily, when they installed this, they actually left a gap. So while we're preparing for the cutover tonight, we can just slide these things right in and kind of get staged without impacting any of the business. One of the big things that's playing into our favor here is just how well this entire MDF, actually the whole place, is wired up. So everything from the cables, the Ethernet cables that go into the patch panels is very clean. It's very well labeled, and it's making this transition so much easier. And you can kind of see the entire backbone of this building. All the connections between the MDF and the IDF are single mode fiber connections. And the internet connection comes in over here, comes in via a fiber, terminates over here into a Juniper switch, which is very common for ISPs. And then it's just brought over into the Peplink. So a little bit of room for improvement with getting a second WAN put in here. But overall, we got a really good base to build off of.
We pulled the Cisco firewall and replaced it with a Peplink Balance 1350 EC, which is frankly more router than headquarters will ever need. It'll handle over 5,000 users and push 25 gigabits of throughput, so there's no ceiling that they're going to bump into. And the dual hot swappable power supplies means that if one ever dies, the other one keeps the whole network up without any downtime, which is especially important on race day. But here's the real reason that we picked this firewall. It can do up to 2 gigabits of SpeedFusion VPN throughput and manages up to 800 SpeedFusion peers. So that means it's got plenty of horsepower for every truck, timing stand, and fuel rig phoning home from racetracks all over the country.
This was basically open heart surgery on the core of their network. Now, we have a team of 3 from Crosstalk here, and we spent an 18-hour day planning, configuring, and then replacing all of the Meraki gear with the Peplink stuff that you see here in this rack. There were a couple of issues that we ran into. They have an access control system here, and on these Peplink switches, the rightmost ports are all 2.5 gigabit. And so some of those access control readers, just by virtue of where they are in this network, were plugged into the 2.5 gigabit ports, and they were unable to negotiate at that speed. So once we figured that out, it was a pretty easy fix. We kind of just rearranged some of the wiring and got the access control readers into 1 gigabit switches where they actually were able to negotiate, and they negotiated down to 10 megabit half duplex, which apparently is just the way they work. The other main issue that we ran into had to do with their Cisco Meraki MR44 access points. They have about 40 of these spread throughout the building. And while they do have Peplink access point replacements, we weren't doing that this week. They were going to replace those slowly over the coming months, leading up to the point where the licensing on those devices is set to expire. But for 2 out of the 19 switches that we replaced, we noticed super high CPU utilization, right? The switch was like basically pegged at 100% CPU, and those happened to be the 2 switches where all of the access points for the network were plugged in. So we still don't really know what happened there. We took some diagnostics logs with the access points plugged in, and then took some diagnostics logs with the access points not plugged in, and we sent all of that to Peplink, and hopefully they'll be able to kind of lab that out and figure out why that was happening. But since Since they are replacing all those access points over the coming months anyways, we kind of just came up with a Band-Aid fix. You'll notice that there's one Cisco Meraki switch still in the rack here. Essentially what we did is we just plugged all of the existing Meraki access points into this Cisco switch, and then as they swap out the MR44s for the new Peplink access points that they purchased, they will just put the new Peplink ones back into the Peplink switches. Now, while it's a drastic step to completely rip out the core of a network and replace it, the benefit is that their Cisco licensing was coming due next year, and the licensing alone was going to be about $100,000 for the equipment that they had on site here. On top of that, you can't have end-of-life hardware with Cisco Meraki. So they were going to have to replace a good chunk of that hardware that was coming end of life, which was going to add another $30,000 onto the price tag. So they were basically looking at a $130,000 licensing bill coming due in about a year, and that would have taken them for another 3 years. But with the Peplink gear, while there are annual recurring licenses, it's more of just an extended warranty, and Prime Care gets you access to InControl, which is the sort of central cloud configuration portal for these devices, and it's nowhere near as pricey as Cisco Meraki. So replacing all of their Meraki equipment with Peplink, including the license fees and including our fees for installation, saved them $80,000 over the 3-year term. So with this part of the project out of the way, we were now able to focus on the connectivity for the remote racing teams, and that's what we're going to test out next.
I want you to stop and think for a moment about the hardest part of this install. Every racetrack hands each team a single fiber feed, and it's on the team to take that feed and distribute it in real time to the engineering trucks that are parked in the paddock, to the monitoring stands down in the pits for 3 or 4 different IndyCars, and it also has to get all the way back to the control room at headquarters in Indianapolis. Every one of those locations is on a completely different internet connection. It might be fiber from the track, or Starlink, or 5G cellular, Wi-Fi as WAN, whatever works for each individual spot. Then, all of those connections need a backup too, just in case the primary feed drops mid-race. We spent our last 2 days on site in the RLL garage configuring and testing all of this so that when the IndyCar season starts, they don't miss a second of the action.
So this is one of the engineering trucks for one of the cars, and you can see that there's places for people to sit down, and they've all got these screens right here where they can broadcast all kinds of different information, almost like a NASA control center. So this truck will have the Balance 310X, we're gonna have a switch, and then it will also have the AP Pro AX antenna that will be outside somewhere. This thing is rugged and waterproof. It is gonna be perfectly fine outside. And then they've got a number of portable stands. So this one isn't completely unfolded, but you can kind of see that there's screens up in here and people will be standing here. This is one of the timing stands. Here's another one. This is a viewing stand they can pop this up right next to the racetrack and people can get an elevated view of what's going on. And then of course they've got screens right up here as well. And then there's also stuff happening right here at the fuel rig. Now, this entire set is typically duplicated for each car that they have racing, and they might be in completely different locations around the track. So for versatility, some of these extra pods and stands might be connected using Wi-Fi as WAN to the engineering truck, or if they're close enough, they might just be hardwired. Or if they can't be hardwired, or if they're too far to use Wi-Fi as WAN, you can use 5G cellular, or you could use something like Starlink. At the IndyCar races, they also get a fiber feed that has very specific VLANs feeding into their equipment for race telemetry, car position and stuff like that, as well as IP camera feeds from around the venue.
It's tough to explain how we pulled this off without getting really deep in the weeds of virtual networking, but here's the short version. Every truck, stand, and fuel rig has its own router with 2 or more internet connections. Peplink Speed Fusion securely ties every one of those routers back to the Balance 1350 EC at headquarters, and they all share a single Layer 2 broadcast domain. So every piece of equipment, no matter where it physically sits, lives on the same virtual subnet. When the team's out at a race, that single fiber feed from the track reaches every truck, every stand, and headquarters alike as if it were plugged into the same Layer 2 switch sitting in one room. This is called Layer 2 Speed Fusion Bridging, and it ticks every box that RLL was asking for. Now, Layer 2 bridging itself isn't unique to Peplink, but doing it reliably in real time over a bonded mix of fiber, 5G, Starlink, and Wi-Fi that's different at every location and prone to failure, that's where Speed Fusion pulls ahead, and that's the part other vendors can't keep up with.
We've spent the afternoon setting up what we hope is a true-to-life demo environment for the IndyCar network, what these IT folks are going to see when they're on site at an actual Indy race. And let me show you what we've done here. So, on the table here, we have our Balance 310X router. That is being fed its WAN by Starlink. So we have a Starlink high-speed dish that's outside of the garage here, plugged into the WAN port here. And then we're also feeding the LAN into this switch. Also fed into that switch is my laptop right here, which is simulating an IndyCar broadcast. But in this case, it's not an IndyCar broadcast. It's one of my Peplink videos that we are just live streaming through VLC and pushing through the network and then out the Starlink up to the Speed Fusion hub in the server room in Indianapolis. And then Dave, the Speed Fusion hub, what does it do from it once it's receiving that signal?
Yeah, so once it gets that signal, just like a VPN, it has this really cool technology called a Layer 2 span. So it's not just doing some sort of repeating, it is truly making a Layer 2 connection site-wide, not only at the headquarters, but also here at the track.
So right here is the timing stand. And in the timing stand, we've got a Max BR2 Pro router, also a little switch right here. Now this one is completely independent WAN-wise. This is being fed its internet by a Starlink Mini. So not the same Starlink that the engineering truck is using, a completely different internet connection. And then that is also picking up the broadcast on that virtual Layer 2 domain. Now, this is usually much higher, but we don't have the space to actually unfold this thing completely. But if you come over here, you can sort of look in the side here and you will see that that same exact broadcast is up on the screens inside the timing stand. In addition to that, this is a viewing stand, okay? And the viewing stand has a very similar setup. But in this case, we've got a Max BR1, a tiny little router right here. The WAN source for this one is Wi-Fi as WAN over to the timing stand, right? So this is picking up its internet also from that Starlink Mini, but with Wi-Fi as WAN. Now, if we wanted to, we could plug a hardwired Ethernet connection in here for internet. We could use a 5G cellular modem. We have options for that type of redundancy. We could also bond multiple connections together. So for example, if we wanted to have Starlink plugged in here and a 5G cellular SIM, we could do that as well. And if you come around this side over here, you can see that I'm also being broadcast to this location right here. All right, and if that wasn't enough, because all of the stuff that we showed you before was simulating what's going to be at the actual track where the race is taking place. But here at RLL Racing headquarters in Indianapolis, they also wanted to be able to see that same feed in their race operations center. So let's head on in here. And as you can see, the same stream is also going on here in Indianapolis because this is where the Speed Fusion hub is. So this is almost considered local to that virtual Layer 2 network. Ultimately, what's going to happen, of course, it's not going to be crosstalk videos playing on this screen. It's going to be camera feeds from the track along with race telemetry over here showing the position of the vehicles and, other race data. All right, so Andrew here has been helping us set up this whole demo environment. In fact, you were out in the 20-degree snow setting up the big Starlink dish and all of that. So thank you for helping us get all this done. But now that it's up and running and we're proving that it actually seems to be working, what do you think? What are your thoughts?
Well, again, it's, we can sit down and talk for a long time and make plans and, kind of talk about how it's actually going to function and what the ideal scenario will be. But, at the end of the day, you have to kind of execute. And I think that's effectively what's happened. I mean, every single piece that, I would expect to work really has. We can always build onto it more and do better things in the future. But this is a rock solid foundation to build for the future.
Yeah, absolutely. And like I said, we're looking forward to the live test.
Oh, yeah.
So it's been a long week here in Indianapolis, and thank you, Dave, and thank you, JB, for helping out with this installation. It has been a lot of work, including 0-degree weather and at least an 18-hour day to get the whole core of the network ripped out. But we're pretty happy with the progress that we've made. However, we do need to get this thing working live. So the next thing we got to do is get to an actual race. Welcome to Long Beach. So we are here at the Long Beach Grand Prix because when you have a complicated network setup like this, it's one thing to just test it in a lab environment when you can control all the variables, but it's a completely different thing when you're out here in the wild in an actual remote deployment. So we wanted to come out here, see it in action, and make sure that everything is working perfectly.
So I'm going to show you the yellow box here. So what this is our direct feed to IndyCar's telemetry, network, and IPTV. What we do with this is we hook up all of our trucks directly to the fiber and then we daisy chain off of these. Sometimes we can have issues with the IndyCar network where we have to rely on Starlink. So the 500 has really good infrastructure. We can leave our trucks on pretty much the whole month, but when we come to street tracks like this, it's kind of a little bootleg sometimes. So having the extra reliability like a Starlink comes in clutch. If they drop, then we have to make sure that there's redundancies, right, pretty much in everything we do.
So there you have it, a successful deployment for the RLL IndyCar racing team, and I think one of the more complicated network setups that we've ever designed, but ultimately it's working great, and now RLL has excellent communication between the pit, the paddock, and even the folks that are still home in Indianapolis. So if you need this type of network design or any type of network design, make sure you contact Crosstalk Solutions. And also if you're looking for any sort of 5G unlimited data SIMs, we now have Crosstalk Mobile up and running. Check it out at crosstalksolutions.com and crosstalkmobile.com. All right, thank you guys so much for watching, and we'll see you in the next video.